Unit 3 is IS-3 Atoms, Elements, and Molecules. Dmitry Mendeleev is considered the creator of the periodic table of the elements. We utilize his periodic table today. Mendeleev's original periodic table included the 63 known elements at that time. He grouped them in columns based on similar chemical and physical properties, such as lithium and sodium react violently in water and produce hydrogen gas. He ordered them to the right based on their atomic weight. He determined that there were elements unknown based on the patterns he saw, so he left blanks in his periodic table. Here's the original periodic table. You can see the blanks around the periodic table, and some of the elements on the far right encompassed 2 rows. A period is a successive occurrences of the same state in an oscillatory or cyclic phenomenon. In other words, something repeats. The law of periodicity, or the periodic law, states that the physical and chemical properties of the elements recur in a systematic and predictable way when the elements are arranged in order of increasing atomic number. Many of the groupings we used in today's periodic table of the elements is similar to Mendeleev's periodic table. We have since discovered many more elements up to 118. Most of the elements on the left of the table are metals, whereas the ones on the right are nonmetals. We'll discuss these terms later. Each of the columns, areas going up and down, are called groups. Each of the rows, areas going sideways, are called periods. Many of the groupings came from patterns noticed when many scientists over hundreds of years studied the elements. Patterns are a cross-cutting concept. For example, this graph shows how difficult it is to remove one electron from an element, and that the last one in each period had the highest. Each of the groups have similar and physical properties. There are 3 subatomic particles that make up an atom: proton, neutron, and electron. Each of the elements on the periodic table were named based on the number of protons only. As there are more protons, there are more neutrons and electrons, which makes the atom larger. Again, there are 3 subatomic particles that make up an atom. A proton uses the lowercase p and a superscript plus symbol. Has a weight of 1 atomic mass unit, or AMU. An atomic mass unit is similar to kilograms at a certain amount, but we use 1 atomic mass unit to use for atomic particles. Charge of positive 1, or just positive, and they are located in the nucleus, which is the center of the atom. A neutron has a lowercase n with a 0 as a superscript. A neutron has a weight of 1 atomic mass unit, just like a proton. A neutron has a charge of neutral or 0. And a neutron is also located in the nucleus. An electron is a lowercase e with a negative symbol superscript. An electron has a weight of 0 atomic mass units. While an electron does have some weight, it is very, very small, so we round it to 0. An electron has a charge of -1, or just negative, and electrons are not located in the center in the nucleus, they are located around the nucleus. Again, the nucleus is where protons and neutrons are located. Electrons are located around the nucleus in areas we call shells. The name of the element is based on the number of protons. The number that is a plain digit on the periodic table, like 1, 8, or 11, is called the atomic number. It means the number of protons. We'll talk about the lower number later. This is the class periodic table. I highly recommend downloading this periodic table and writing on it for notes. It will help you with assignments and tests. We will now go over all of the elements you need to know the names and symbols for. Number 1 is hydrogen, H. Notice that it is a capital H. 2, helium, capital H, lowercase e. You must use capital and lowercase in that way. You cannot do two capital letters. 3, lithium, Li. 4, beryllium, Be. 5, boron, B. 6, carbon, C. 7, nitrogen, N. 8, oxygen, O. 9, fluorine. Notice that fluorine is spelled F-L-U like the flu, fluorine. F. 10, neon, Ne. 11, sodium, Na. Notice that sodium does not match its two-letter abbreviation to the original word. The original word for sodium was nabium. That is the Latin form, and we use that today. 12, magnesium, Mg. 13, aluminum, Al. 14, silicon, not silicone. Silicone is a type of plastic. Silicon is an element. Si. 15, phosphorus. Notice that phosphorus is spelled with PH. Phos for us. P. Sulfur. 16. In other countries, they tend to spell sulfur with a PH again, just like phosphorus, but in America we don't. S. 17, chlorine. Cl, again, that is capital C, lowercase l. 18, argon, Ar. 19, potassium, K, that's another Latin one. 20, calcium, Ca. 21, scandium, Sc. 22, titanium, Ti. 23, vanadium, V. 24, chromium, Cr. 25, manganese, Mn. A lot of people mix up Mn and Mg. Manganese is Mn. 26, iron, Fe. Again, that's another Latin one. 27, cobalt, Co. 28, nickel, Ni. 29, copper, Cu. That's another Latin. 30, zinc, Zn. 31, gallium, Ga. 32, germanium, Ge. 33, arsenic, As. 34, selenium, Se. 35, bromine, Br. 36, krypton, Kr. This krypton is the same as the krypton in Superman. However, krypton is actually a gas, not a rock. 37, rubidium, Rb. 38, strontium, Sr. Notice that this skips. We are not going to learn all of the elements. 42, molybdenum, Mo. 46, palladium, PD, 47, silver, AG, that's another Latin one. 50, tin, SN, again another Latin name. 51, antimony, SB, another Latin name. 53, iodine, or some people pronounce it iodine. I, that is a capital I. 54, xenon, XE. 55, cesium, CS. 56, barium, Ba. 57, lanthanum, La. 74, tungsten, W. 78, platinum, PT. 79, gold, Au, another Latin name. 80, mercury, Hg, another Latin name. 82, lead, Pb, another Latin name. 83, bismuth, Bi. 89, actinium, Ac. Uranium, numbered 92, which is found on the bottom of the periodic table, U. Each group has two sets of numbers, numbers from 1 to 18, Roman numerals using A to B. A groups are the regular groups, and group B are the transition metals. Metals are on the left of the periodic table. The line that separates the left and right are the red boxes. Nonmetals are on the right of the periodic table. This also includes hydrogen on the far left. The line that separates the left and right are the red boxes. Metalloids are on the line that separates the left and right of the periodic table. Characteristics of metals. Metals have a shiny look, which are a physical characteristic. Metals are ductile, which means you can form wires with it, which is a physical characteristic. Malleable, which means you can hammer it without it breaking, which is a physical characteristic. Conducts heat and electricity, which is a physical characteristic, and tends to lose valence electrons, which is a chemical characteristic. Nonmetals are the direct opposite. Dull, not ductile, not malleable, does not conduct heat and electricity, and tends to gain valence electrons. Metalloids have a mixture of characteristics of metals and nonmetals. Metalloids can conduct electricity, but only by increasing the temperature of the metalloid. Typically, we use metalloids in computers. The group names are as follows. Group 1A, again that's a capital I, and that stands for the Roman numeral 1. Group 1A, alkali metals. Group 2A, alkaline earth metals. Group 7A, 7 is because the V stands for 5, and each I stands for 1 each. So 5 plus 1 plus 1 equals 7. Group 7A are halogens. Group 8A are the noble or inert gases. Inert because these gases do not react with other chemicals. And noble comes from the fact that they were given the analogy of kings who did not interact with anyone below them. Here's a periodic table showing the different group names. As you can see, alkaline metals, except for hydrogen, starting with lithium, go down and are all alkali metals. Group 2 or 2A are the alkaline earth metals. The transition metals are all in the middle, as we discussed earlier. And then going to the right, 7A or 17 are the halogens. Group 8A or 18 are the noble gases or inert gases. There are special period names for two of the rows that are below the periodic table. Lanthanides, which starts with number 57, lanthanum, goes to number 71. And actinides, for actinium, number 89, goes to 103. As you can see, they are down below here in purple and red.